This sidewalk video captures the demolition of the Jacobs Building at NYU Tandon School of Engineering in Brooklyn, a process currently underway. Named after Joseph J. Jacobs, a distinguished alumnus and founder of Jacobs Engineering Group, the building represented Tandon's commitment to innovation. Located on a campus with a long-standing legacy in engineering education, this demolition marks a significant step in the school's ongoing modernization efforts in downtown Brooklyn. In this video, we will also feature an interview with the architect and constructor to dive deep into the architectural and engineering aspects of the building and its demolition process. The interviewer for this sidewalk is Lawrence Chiarelli, the program director for the construction management programs in the Department of Civil and Urban Engineering. The video documents this transition, offering a look at the end of one era and the beginning of a new chapter for NYU Tandon.
Okay. Hello, I'm Professor Lawrence Chiarelli from the Department of Civil and Urban Engineering here at the NYU Tandon School of Engineering. We are in what was up until now known as the Jacobs Building, which will soon no longer be the Jacobs Building because it'll be gone. I have with me here some colleagues. I'll let each of them introduce themselves and tell you kind of a little bit about what they do and what their role might be on the project. Or go ahead, Kevin.
Hi. My name's Kevin Daly. I'm a senior associate at Jablonski Building Conservation. We're an architectural conservation firm here in New York City. On a job like this, we would be involved in materials. Frankly, we would be involved in trying to preserve the building. But we're here to try and look at the materials and constructs that would have been used initially on this building when it was built, probably in the late 19th century. I'm going to talk a little bit about what deterioration conditions we would see in a job like this for a building that's 140-something years old.
Now, Kevin's not actually involved with this actual project. Kevin is a mentor on our ACE mentor team. And so,
Team 12.
Team 12. So since conservation and old buildings are sort of his thing, that we figured this would be a great opportunity to provide some commentary on that. Gentlemen?
My name is Robert Harker. I am the product manager for Gilbane Building Companies, the general contractor in charge of overseeing this project. Myself and my superintendent, Chad, have been on this job for almost a year now and have successfully taken down the CE building, which is not pictured here. And now we're getting ready to mobilize to take down this 315 J Street building. Okay.
Any interesting observations on what you've seen so far as these buildings, like in terms of historical perspective, or any interesting aspects?
Well, for one, I've never in New York City ever seen a wood-framed structural, like joist type building like this before, with wood flooring, no slabs. It's very interesting. You know, the design, the engineer for record for the demolition has to, check the imposed loads for machinery that we want to have on here. And you'd be surprised, this floor is still pretty structurally sound. You wouldn't think looking at it that you could have some of the equipment that we have parked here able to be stationed here, but you can. And that's, very interesting as well.
Okay. Kevin, you were talking before
from a civil
about
engineering perspective, it's kind of interesting if we can get a look at the ceiling at some point, but we have very closely spaced, very robust joists. And one of the, for the civil engineers, the fun part is, you have intense loads in these spaces, and in a historic building, you often see a fair amount of displacement, right? Because wood bends well before it breaks. So you could have, I've been in old buildings where you can see that the center of the floor is 2 inches lower than where the joists pocket, and that's still very much okay.
Are these 3x12s?
It looks like they're 3x12s.
3x12s, and I bet you if we measured them, they would be pretty close to 3 inches.
They might actually be not nominal 3x12s, but actual 3x12s. I don't remember the exact date at which that nomenclature changed, but as you know, like a 2x4 isn't actually a 2x4, but you can find old buildings where it's exactly 2 inches by 4 inches because that's the way they wanted it.
Right, and I can see they also have some diagonal bracing here.
That's right. Obviously, one of the things about these spaces being structurally sound is that you don't want to actually have the joists to twist or to fall over domino style. So those cross braces are meant to sort of link them. It's a weird way. It's cross bracing like you'd see on a steel structure.
You wouldn't see this in wood framing today. This kind of cross bracing.
You might. Well, it wouldn't be done the same way. This is actually really robust. Those are big honking pieces of wood to stabilize that. But it's in keeping with this. I'm expecting that this was a light industrial building in the last part of the 19th century. That there was machinery and workmen and piles of material on every floor, and they needed to make sure that that stuff didn't end up on the lower floors accidentally.
Okay.
As they say.
Over here we were looking, actually,
We could just get over
This
here.
column is covered up, but if we can come around.
I also think we were talking earlier on our way in that it might be that this building was constructed in phases, right? I mean, even separated by decades.
Yes.
Because the columns in the space just off to our left, that way, to the north, are wood columns. Sometimes they've been laminated and bolted together to have, they think, to retrofit a little bit more structural stability. But in this part of the building, the main columns are enormous pieces of cast iron. Looks like single castings. And we even think because of the way that the joists of the ceiling above us are framed out around the columns, that there might be sort of continuous structure going, foundation to top.
If you can turn and look at the top of this column here, you can see the framing. Can you tilt up that far?
You can see the joist that actually intersects with the line of the column is actually hung from a secondary piece of framing. So the joists don't actually engage this beam. And
So we're now at an adjacent portion, looks like may have been either two separate buildings or a building where part of it was constructed slightly differently than the other.
it was really common historically to build a core building, and then if your business succeeded, to add to it, and if at all possible, you'd try and make it as much pass-through as possible because one single industry. So I'm willing to bet, based on what we're just about to talk about, that we're in the earliest part of the building, and we were just filming in the later part where more advanced building technologies were available, and they used them. So in this particular case, since I'm pretending it's an earlier part of the building because there's a wood column. We were talking about cast iron columns earlier. This is a pretty robust, like 9x9 or 12x12 column. And the floor structure is hung off of that. And then at some point, there was a decision that either they were concerned about or they were actually aware of, a reason to worry that that wasn't enough. So they sistered up these big pieces adjacent, which are, what, 2x6s?
No, is that two or is that three?
I don't know, maybe 8?
We're going to actually measure this.
There you go.
Okay.
About 2.5, 5/8.
Okay, so that would be a newer 2x than
Bolted
a newer 3x than
Exactly.
than a full 3x. So
Exactly.
this is separately from a later period.
This is a separate piece, this is a separate piece, and then they were bolted through. You can see they staggered them
Yep.
side to side. So the idea here is they must have become aware at some
Okay.
point that they needed extra, probably lateral loading, to prevent buckling, I'm guessing, just because it doesn't look like the column goes below the floor.
Right, so it's not adding to the vertical load capacity.
I think that's correct.
But
It's
it is
just stiffening it.
It is looks like it's definitely a newer 2x8 because it's 2 5/8 by 7.5.
There you go.
So on a steel building, those two pieces of wood sandwiched on either side are acting as stiffeners
Right.
in the same sense that you would install on like an I-beam,
Yes,
basically.
I think that is exactly, the analogy is great, absolutely the case, because, I'm sorry to apply common sense, but the idea is just the same, that if we're not able to carry the load continuously, then at these points, the old central column is doing all the work. In this particular case, doesn't look like the added pieces go any farther than where we're standing.
It's interesting. You can see the little bit of decorative nature in the structure here.
Yeah.
When you get about a foot up off the floor, that the corners look like they've been chamfered.
Yeah.
So they want
And that's decorative, but it's also functional in the sense that people walking around here with machinery and the like would lop off the corners, and if they shattered the corner a little bit more than they needed to, then you could cause a little bit of structural damage to the column. Having it chamfered like that decreases that risk.
Okay. All right. Okay, we've come up to the 5th floor, and you can see if you look up at the ceiling here, there's some skylights. What used to be skylights, and it's plywooded over, I guess, where there used to be glass all the way up at the top.
So we'd see they've actually got, and I don't know necessarily what the age of this lay light is, but this horizontal section is called a lay light, and it's meant to sort of distribute the light as evenly as possible. And I think, unless I'm mistaken, it's a north-facing shed skylight, right, to try and get a whole bunch of indirect light so we don't have a lot of, there's a whole lot of building technology in early industrial buildings designed to get as much light as possible into the center of the building so that you don't need a lot of gas light or electrical light, which is expensive in that era and hard to get. So you'll see all around Soho, for example, all these light industrial buildings that have vault lights that grab street light that's hitting the sidewalk and getting it into a basement space. I actually worked in a factory that became gallery where there was a sub-basement, and so the basement actually had vault lights so that light from the street could get down 2 levels into the sub-basement.
Well, that's
it was
even,
worth it to them.
if you go, particularly in the Soho area, you walk around on the sidewalks, you often find like glass blocks that are actually built into the
Huge
concrete
technology
sidewalks.
of these cast iron or steel plates that are pocked with hundreds and hundreds of small circular or square holes, and their glass is set into them or cast into them. And so, yeah, the whole idea is to maximize, while being structurally sound, getting the maximum amount of light inside the building.
Any idea what I see a couple of, about 3 rows of conduit up there. Is that?
I think those, Chad, let me know if I'm wrong, but they look like they're black. They're cast iron pipe. Yes. And I would think they'd be used for heating, to melt ice or water might be condensating in there.
Condensation is a huge issue in old buildings because it's single glazed. IGU is a very modern invention. So, you have a hot, wet interior space and a cold, dry exterior space. You get a tremendous amount of condensation. So those pipes may have been, in that model, would have been there to throw a whole lot of heat on the inside of the glass to try and dry the water out before it was causing problems inside.
Okay. Now, I was asking you a few minutes ago, you got equipment up here, some little tiny backhoe. Looks like almost like a kid's play park or something.
So obviously on this project, the demo contractor, wants to use equipment where possible to expedite removal of material from site. As we were saying before, weight of the material is a constraint you need to factor in. As you can see, the Bobcat machines over there with the bucket on the front are going to be used to take demo debris and push it over. What's going to happen is when we start demolition, we're going to remove the elevator shaft, remove the elevator car, and then use that as a debris shaft to drop material down to the cellar, which there will be another one of these machines down there to push the material out over to where we have the building down over there so that a larger equipment can pick it up and put it into minis.
Do you have to actually do anything inside the shaft to use it for dropping debris, or you just keep the doors closed on the lower floors?
There are safety precautions needed to put in effect. We have to get a permit that has engineer drawings for it.
Right.
It's going to involve keeping the floors closed off that you're not using. On the bottom, you're going to have almost like 4x4 posts setting up a whole designated area so that no one walks near it.
Okay.
It keeps workers away and makes it so that everyone is aware that, hey, this is an area where material is coming down, stay away from it.
Okay. And then, so obviously we demolish from the roof down. We build from the bottom up, but we take it down from the top down. So is the roof demolition going to be from up on the roof, or is it going to actually occur from down below here?
Chad, you're more familiar with this than me. Let's get
It's a combination of both. So
Okay.
you'll have guys on the top with the jackhammer taking down the roof, and then you'll have this machine over here, that'll help grab.
So material will basically be dropped down onto this floor from the roof demolition, and then basically pushed out through the elevator shaft down to the lower floor.
Yeah, and it's basically a 4x4 operation. And the intention is then we get down to the 3rd floor, you have to, hand demo. This is considered hand demo even because the guys will be using, as you said, jackhammers, hand tools. And then what you gotta do is clear a certain amount of space from the side of the building to the neighboring building in all directions.
Right.
And you kind of leave a center core of the building.
Okay.
3rd floor down, then we can come in with a big excavator and take it down.
Take the core down.
Take the core down, and more efficient than having manpower just keep jackhammering away.
How tall can you reach from the ground with an excavator to do that?
So for the CE, the CE was 3 stories.
That was a smaller building.
That was a smaller building. So I would say maybe the 3rd floor.
Okay, so the top 3 basically is by hand, and then the lower 3, you take down the perimeter by hand, and then you pull the core down with the heavier machinery.
Correct.
That's again more than just the sort of simple material problem of getting the stuff safely. Well, getting the stuff down, it's getting it down safely for the workmen and for the public.
Yes.
I mean, it's a busy street right there.
Right.
So how to get this stuff out without putting people at risk is an important part of whatever design there is.
To that point, the cool thing that happens is that once we take, let's say, half of this floor, the floor above, we'll put steel beams, and they'll go from this floor to that floor. This is how the machines will start to go down each floor. They'll ride the
Oh, okay. You basically build a ramp.
Yeah.
So you're going to go ramp down, make a hole,
and then
essentially,
we'll
and
take
go
the
down.
scaffold down floor by floor. So
The temporary parking structure. Ramp down, pull away, and then keep going. Amazing.
Okay. Any other? Let's see. We've got some pretty simple
I wish we had a better
up
way.
here.
So this is our same right chamfered corner column. It's just now much slimmer because we're higher up and the loads that are imposed are less. And we aren't using it's shorter.
Yeah, it's a little bit smaller, right?
And they haven't, and whenever they did that retrofit stuff, they didn't bother to do it up this far because at this point there's not that much above us except for snow and rain. Yeah, several. So
So this is the Jacobs Academic Building.
right.
That's this over here. This is all Rogers Hall, and actually this whole wall of Rogers Hall, this was all just redone about a couple of years ago.
Insulation. So the old roofing, or I'm sorry, relatively new roofing and insulation. That's a sign that it's new. And they cut down to whatever this slab was. So it's a reinforced slab, and then did this temporary installation up on here. I was also going to say, so obviously everything about the top of the building is about how to shed water, right? And how to make sure that we don't end up with water inside the wall. And the cross joints, these skyward facing joints. So first of all, bricks are tons and tons, 7 linear feet of joint per square foot of brick, roughly speaking.
Right.
So there's a whole lot of room for water to be absorbed between the bricks. So on the top of the wall, that's why you would use stone or sheet metal or some other material that's more waterproof, except now the problem is concentrated at those cross joints, those skyward facing joints. So you can see somebody did some careful work removing something from here. That's why we had sealant or metal joint covers or some other type of flashing to keep water from going through the joints.
You can see there's actually some type of a fastener sticking out.
Right, on either side of the joint. So
Yes.
they may have had some type of cover installed and anchored into the joint.
Right.
It's hilariously more and more minute because now, of course, the anchors are vertical shaft through which water can pass. So what are you setting it in sealant? Are you doing something? Are you putting gaskets around the edge? How are you, smaller and smaller scale efforts to try and waterproof the top of the wall?
All right. The beams join over
Yeah, the beams join over.
that.
So now I can't believe I'm blanking on the
Is
phrase.
that called a saddle?
I don't know what that would have been called at time.
How is it fastened to the column? Is
It's sitting. No, it's sitting on top. It's
Right,
by
so
the solid
the
plate.
thing is,
yeah.
it's a plate, but it's cast or welded to have that upside down cup, right? Just so that the column is going into it.
So it's just a cap.
Yeah,
It's a cap,
And
yeah.
of course, the load of the beams are keeping it in place. It's not going anywhere. I mean, obviously, we do all kinds of additional connections now for seismic or fire protection reasons.
I don't even see any bolts or.
That's what I mean. It could conceivably be, at the time they thought there's going to be tons of weight on top of this. It's not going anywhere.
What is that? There's in the Japanese, there's a what is it? There's a large temple. There's a type of Japanese construction that is very resistant to seismic effects because the joints are actually flexible, and if there's a seismic event, the building the building essentially moves.
I know that works in wood temple construction. That's
Yes.
that's part of the reason why temples survive all these earthquakes. But I don't know if it works at a scale, at an industrial scale. But yes, most definitely.
But it just
the
it
majesty
reminds
of it-
me of that.
The best part about that as a technology is from the preservationist, the amazing thing for us to talk about is that as part of the reverence for the shrine, there are a few of them that are dismantled and completely rebuilt every 20 years following the original design as a means to sort of keep it as new or as an act of devotion or what have you. And so it's sort of the old the ship of Theseus idea, like, is this an old building or not? It can never be more than 20 years old in terms of its material, but that exact design has been there since the Middle Ages. Huh? Yeah, maybe they, do you think? No, I'm not sure. This wood looks the same as that wood. So.
Does that brick look newer?
Well, that brick is newer.
Yeah.
This is infill, right?
Yeah.
So this has been painted a zillion. This is originally exposed. That was originally a window. At some point, they needed to either have it be a firewall or they just were closing up the opening and they decided to brick it up.
Yeah.
But that was after the days in which it was painted. So there was already sheetrock on these walls or sheetrock on these walls because they enclosed it and covered it and they didn't bother to paint it. So this paint predates this.
Right.
This sconce predates this paint. This channel was cut after all this happened. It's fun to try and, it takes common sense really, but you can learn a lot about the building's history just to see what got painted and what didn't.
So it looks like something was recessed. Recessed in there.
That's right. They came and cut out that.
Can that have been a sill for the window?
No. It's right about it, but if the paint's telling the truth, this is the bottom of the window opening. There may have been a sill or saddle above it.
Yeah, there's a soldier, there's a, what is it?
Header course?
Rowlock? Header course.
Yeah.
No, wait, no, but it's
rowlock?
Rowlock, right? Isn't that the ones that are?
Yes, turned on their end and set header style.
But they're not standing on, not a soldier course.
The soldier, no, it's
soldier?
sailor, no, soldier, sailor, rowlock.
Okay. Anyway. Okay.
Huh. No, so something happened here, interestingly enough. Whatever the pipe was that was chamfered in the wall turns out, because this is the cut is weirdly round. And this is probably more your traditional, were you showing before, Larry, is this is your traditional, a roll lock course, and then maybe some type of like cement bed, and there would have been a stone sill. This is an immensely thick wall, and it looks like it's built in 2 phases. Huh. So I think maybe this was the original wall and this was added when there was a change. There's also a small chance, I'm trying to remember looking at the old city plans here, because there were like row houses and residential buildings to the south of this before they built the concrete building. So that may have been the party wall with the adjacent buildings, and when they knocked it down, they couldn't knock down the party wall.
Right, Kevin, we were looking the other day, there's a website with the slide where you can put in 2 different years and you can look at the exact same aerial photo showing, and you slide it over and you can see here it was in like 1910, here it is in 1940.
When they did aerial surveys, so there's 10 of them between 1990 and the present day, and then the one before like 19. No, I mean to say that's the problem is how many aerial surveys?
1990 or 1890?
How many aerial surveys do you actually have? So before 1990, there's 1951 and 1924, and that's it.
There's a website called 1940s.nyc.
Absolutely, there is, yes.
And they have they're good quality photos. I don't know what happened in the 1980s because I'm looking at the photos from almost 100 years ago.
Yep.
Beautiful. Then you go to the 1980s, and every photo of every block is grainy and poor
I think it's
quality.
more about they were deciding to either the microfiche, they were trying to store absolutely everything on much less.
They're probably using an Instamatic camera.
It is undoubtedly much cruddier. It's hilarious if that's the case.
Yeah.
It's true, but yeah.